All right, we are moving on in our unit on polynomials and factoring, and this particular video, this topic will cover factoring x squared plus bx plus c, and we are really just going to do a bunch of examples. I'll do a brief introduction, but mostly this is a lot of examples that we'll be doing today. So here's our goal. Let me start off with a x plus 3 and x plus 2. Okay, and we can multiply that out. We call it foiling out, and that's going to turn into x squared plus 5x plus 6. And those two algebraic expressions are absolutely equivalent. One is more useful than the other, and the other is more useful than the first one, depending on the situation. But they're absolutely identical, not identical, but equivalent algebraic expressions. So what we just did is we multiplied, okay? What we're going to try to do today is undo that and go backwards. So this is multiplying and this is factoring. Okay? And again, I want to remind you, I've said this before, but I want to remind you that a lot of what we're doing in this unit seems abstract, and it is probably somewhat abstract for you. But once we get to our quadratic functions unit, there are just some incredibly useful real-world applications for this. Okay, so this is a skill that we're developing in this unit, which we'll then apply in our next unit. Okay, but anyway, today we are thinking about how can we factor, how can we do that multiplication back in reverse? How can we undo the multiplication? Okay, so one thing to I guess notice here, and this will apply a lot. And by the way, some teachers have varying different ways of teaching this. There's different graphic organizers that students use. There's different types of tools. There's grouping. There's a method called the X box. There's a variety of ways. And I'm not going to cover any of those specifics right now. I'm just going to cover what I think is the most basic way of doing it. And if you find a method that works for you, you should definitely stick with it. But I'm a fan of just practicing and being familiar with your times tables and your factor tables, and using that to factor these guys pretty effectively and efficiently. So I hope you can see that this 3 and this 2, they added together to get the 5, and they multiplied together to get the 6. Okay, that's a rule that we'll be following quite a bit. Okay. And definitely we can use that in every single problem we're doing today, okay? In our next video, things get more complex and we can't just follow that rule of thumb, but we can use that rule of thumb today. So let's do it. Let's do some examples. So we are looking for two binomials whose product is this x squared plus 10x plus 21. Okay, so first thing, I just like to throw in my x's, and remember the f part of foiling is the first two terms, x times x. That's going to give us this x squared. Okay, so we're all set there. And then I always like to look at the 21 next. What are some factors of 21? So 21 could be 1 and 21, or 3 and 7. Is there a pair of those that adds to 10? Well, yeah, the 3 and 7 do. Okay, so I'm going to do plus 3 and plus 7. And by the way, it could have been x plus 7 and then x plus 3. Those are the same things. So let's FOIL it and see. Okay, x times x is x squared. Outers are 3x. Inners are 7x. And the lasts are 21. And then we're going to combine like terms, and we get an x squared plus 10x plus 21, which is what we started with. So we did it correctly. Okay. As you get more familiar with this, your check can get a little more efficient as well. Did I need to do a full FOIL check? Well, maybe not. I wanted to show you because it's important, but perhaps you could have just checked the O and the I and the L, because the F term is set up already to be an x squared. You know it's going to be x squared. So you can just sort of check each piece separately as a check as well. All right, let's do this next one, and there's a complicating piece in here, the negative 15, okay? So remember, we're looking for a couple numerical terms that multiply to be a negative 15. And this is another big strategy. We're going to throw in our x's right away because we just have a plain old x squared out front. But to get a negative 15, we need a positive and a negative number. Okay, so it's going to be an x plus and an x minus. And then we can just think of factors of a plain old positive 15. So we have 1 and 15, we have 3 and 5, and that's it. Okay. None of these numbers add to 2, right? We're looking for numbers that add to 2. 1 plus 15 is 16, 3 plus 5 is 8, right? But one of the numbers will be negative. So in this case, we want to imagine making one of our numbers negative, adding them together, and see if we get a 2. And do you see it? I wonder if you can see it. Maybe if we made the 3 negative, we could add it to 5 and get a 2. So actually in this case, we're looking for two numbers that subtract to be 2. And if this is a 5, that's going to be a 3. So x plus 5 and x minus 3. So the difference of 5 and 3 is our 2. Let's FOIL it to check. And I'm going to model another version of foiling. Let's check the f's, or another version of the check. X's get us an x squared, that's good. The last two terms, 5 times negative 3, that's negative 15. The outer two terms are negative 3x plus 5x, and that equals 2x. So that's good. So we got what we started with, okay? So this will be our final answer right there. Okay, so do some version of check. If your teacher wants you to do a more formal check, you definitely should. I'm trying to model a variety of sorts of checks here. All right, it looks like it's getting progressively harder. So now we have 2 negatives in here. Okay, well, let's do it. Let's set up our parentheses. We have a couple x's because we want them to multiply to give us this x squared, and that's our first term. Once again, we have two terms that multiply to be a negative 21. So we have a positive and a negative. Okay. But now they need to add together to be a negative 4. In other words, this number here needs to be larger than this number there because we want the negative term to be larger than the positive term, so that overall added together they'll give us a negative 4. I think we saw earlier that our terms were 1 and 20, or our factors are 1 and 21 and 3 and 7. I can't imagine or think of any way that a 21 plus or positive or negative 21 plus a 1 would result in a negative 4. But I can see if we put in this as a negative 7 and a positive 3. Looks like it's going to work. So let's FOIL it to check out, and to check. And I'm just going to do a verbal check here. X times x is x squared. Minus 7x plus 3x gives us the minus 4x. And then 3 times negative 7 is negative 21. So it checks out. Looks like we did it correctly. So I think you're seeing that there's a little bit of just trial and error, a little bit of guessing and checking, but being clever along the way. So thinking about what your signs are they positive, are they negative, one of each, and thinking about factors, and then just thinking about how you can combine everything together to get what you want, okay? So I'm not following a step-by-step kind of mindless algorithm. I'm just asking you to think about how the numbers are working and then apply your multiplication rules to see if you can get what you need to get. Okay, this I think, yep, this is our last one for this video. And this is another little bit complicated one because of the negative 13 here. So let's set up our parentheses as always. Let's throw in our x's because we want to get an x squared. But look at this. This is a positive 40 right here, right? So we need these two numbers to have the same sign, right? That's how we multiply to get a positive, either two positives or two negatives. But check out this sign, negative 13, okay? So if the numbers in here were both positive, we would never get a negative 13 in that middle term. So we need two negatives inside my parentheses, okay? So this is going to be a negative, and this is going to be negative. And that'll still get us a positive 40 when we multiply, but we need them to be negative, so we get the negative 13. So factors of 40, 1 and 40, 2 and 20. Do some thinking as you do it, like how can you combine these to get a negative 13? Don't just mindlessly write factors of 40. Check them in your mind as you go. 3 doesn't go in, 4 and 10. Those would get a negative 14 if they were both negatives and added together. 5 and 8, hey, that does it. Okay, 5 plus 8 is 13. So a negative 5 and a negative 8 is going to give us a negative 13. Okay, so we can do a check. It will check out x squared minus 13x plus 40. All right, that's a good place to stop right there.